You know how in math class you sometimes run into a problem and the teacher says, you just can't do that? Well, today we're going to talk about a whole new kind of number that was literally invented to break one of those rules. We're talking about complex numbers.
All right, so here's the game plan. First, we're going to look at where our everyday numbers kind of hit a wall. Then we'll introduce the brilliant, simple idea that smashes right through that wall. After that, we'll learn the new rules of the road, see it all in action, and finally, get a picture of what this new dimension of math actually looks like.
Okay, so first things first. Before we can appreciate the solution, we've got to understand the problem. Let's see exactly where our normal, everyday math runs into a bit of a dead end.
The good old quadratic formula. We've all stared at this thing in algebra class, right? It's our trusty tool for cracking open certain equations and finding their roots.
And it works like a charm. Most of the time. But there's this one little catch, a specific situation where this reliable formula just seems to throw its hands up and say, nope, can't be done.
The whole issue, the thing that grinds everything to a halt, is right here. This little piece under the square root sign. It has a fancy name, the discriminant. And when its value drops below 0, we've got a major problem.
And this is the wall we all hit. We're taught from day one, you can't take the square root of a negative number. And it makes sense, right? A positive number times itself is positive. A negative number times itself is also positive. So there's just no real number you can square to get a negative. Game over. Or so we thought.
But here's where things get really cool. Mathematicians are a clever bunch, and they looked at this impossible problem and basically said, well, what if we just imagined a solution?
And the solution they came up with is so simple it's genius. They said, fine, if a number that is the square root of -1 doesn't exist, we'll just invent it. And they did. Meet I, the imaginary unit. Its entire job, its whole reason for being, is to be the square root of -1.
Okay, this right here is the single most important thing to remember in this whole new world. If I is the square root of -1, then it just makes sense that if you square I, you get -1 back. That's it. That's the golden rule. I squared equals -1. This one little fact is the key that unlocks everything else.
So with our new best friend I in our back pocket, we can now build a whole new class of numbers. We call them complex numbers, and they're kind of like a 2-for-1 deal. You get a real part, that's the A, and an imaginary part, the IB. So you can have numbers like 3 plus 5i, or even something like -2 plus I times the square root of 7.
Okay, so we've got these cool new numbers. But how do we actually use them? Like, what are the rules of the road for adding, subtracting, multiplying, and all that good stuff?
And here's the great news. For adding and subtracting, it's super easy. You basically just combine like terms. You add the real parts with the real parts, and you add the imaginary parts with the imaginary parts. That's it. Keep them in their own lanes, and you're golden. Now for multiplication, it's pretty much the same deal. With that one tiny but super important extra step, you just multiply everything out like you would in regular algebra, but, and here's the key, whenever you see an I squared pop up, you just swap it out for a -1.
All right, division is a little trickier, but to do it, we need to meet one more friend, the conjugate. It sounds way more complicated than it is, I promise. To get the conjugate of a complex number, all you do is flip the sign in the middle. That's it. So the conjugate of C plus ID is just C minus ID.
So why on earth do we need this conjugate thing? Well, it's a super clever trick for division. See, to get I out of the bottom of a fraction, which makes things messy, you multiply both the top and the bottom by the conjugate of the bottom. It sounds weird, I know, but it magically makes all the i's in the denominator cancel out, leaving you with a nice, clean answer.
All right, the moment of truth. We've got our new number, we've got our new rules. Let's circle all the way back to that impossible equation from the beginning and see what happens now.
Okay, remember this guy. X squared minus 2x plus 5 equals 0. We figured out that the part under the square root, the discriminant, was -16. This used to be a dead end, that bright red no real root sign, but not for us. Not anymore.
We run it through the quadratic formula, and boom, there it is, the square root of -16. This is the exact spot where before today, we would have had to just stop and say, well, guess there's no answer.
But not now. Now we know what to do. The square root of -16 is just the square root of +16 times the square root of -1. Well, the square root of 16 is 4, and we define the square root of -1 to be I. So the square root of -16 is simply 4i. And just like that, the roadblock is gone. The rest is just simple arithmetic.
And would you look at that? We have our answers. The equation has two beautiful, clean, complex solutions, 1 plus 2i and 1 minus 2i. The unsolvable equation is solved.
So this is awesome for algebra, but what do these numbers actually look like? I mean, are they just an abstract idea stuck on a piece of paper, or can we actually, picture them somehow?
You bet we can. This right here is called an argand plane, and it's a total game changer. Think of a normal graph, but instead of an x and y axis, the horizontal line is for all the real numbers, and the vertical line is our new imaginary axis. So a number like 3 plus 5i isn't just a formula, it's a location. You just go 3 steps over on the real axis and 5 steps up on the imaginary axis, and bam, there it is. This is so powerful because it turns these numbers from a pure algebra trick into something with real geometry. So let's wrap this all up. We started with a problem. You can't take the square root of a negative number. The solution? We just invented I. This let us create complex numbers, which have both a real and an imaginary part. We saw that doing math with them is pretty simple, as long as you remember that golden rule, I squared always equals -1. And most importantly, this isn't just some weird math game. It gives us real answers to problems that used to be impossible, and it's absolutely crucial in fields like electrical engineering and quantum physics.
Which leaves us with a really fascinating, kind of mind-bending thought, doesn't it? We added one single imaginary dimension to our number line, and suddenly a whole universe of previously unsolvable problems opened up. It just makes you wonder what other impossible problems are out there right now just waiting for someone to imagine one more new dimension.